Good afternoon and welcome to our today's lesson. This is Sir Alex of the Ambassador Foundation. The topic for today, we are still doing an introduction to chemistry, but we are going to talk about the chemistry laboratory and very many other things that we are going to discuss today. How has been your day? How have you been doing? Have you been reading chemistry? Have you been reading physics? Have you been doing maths? How many maths have you attempted today? Leo umefanya hesabu ngapi? 2, 3? Actually, you do at least some questions. We wake up in the morning. Hata kama nyumbani kuna kazi, at least do 3 questions, 4 questions like this, and you will be okay. Tafuta maswali mbili za chemistry and physics, you will be fine. And before I move on, I always start by making some announcements. I say this. For those from my school, they know it. I always give exams to those who want to revise at home. I'm teaching here, you learn from me, then after this, you go and do some questions. So, reach out to me through this number. (0740 61 90 25). That's our office number. You call it, I receive it, or my secretary receives it. So don't worry about that. But there are those who are in our, like right now, before I started this lesson, I've sent a link of this YouTube lesson to the group where my people are. So they just know very well that teacher answer lesson. Yeah, if you want also to acquire some exams for revision purpose, one set of exam for one set in a month, you can exams, you take 1 month, 1 English, 1 Swahili, 1 geography, 1 history, 1 theory, all the exams at 1,500. From 2, 3, and 4, one set at 1,000. Someone is asking why. What do you mean from 1 or expensive? Because they are not choosing their subjects, they are still many. So, or if you are from within, you can visit our offices here at the Imuru Ketias building, in the building called GDC Ambassador Studios. You will find exams there, you will find everything. You can even come to our studio, I shoot you a video. Yes, so don't worry about that. But we are here for you. Now, allow me to start the lesson. I hope I'm audible. Those who are following up on me, I hope I'm audible. Let me just confirm from the YouTube that I'm audible. Leo niko peke yangu, my videographer nimemtuma mahali, ameenda kupiga picha mahali ingine. Yes, but let me see. I hope I'm audible. Let me just confirm from. Good. I'm well. Nice. Good. Now we can proceed. Chemistry laboratory. I can now wrap what you are seeing on the board. Why am I so specific? Chemistry laboratory. Because we have physics laboratory, we have biology laboratory, we have computer laboratory, home science laboratory, art and craft laboratory. We have very many labs. So today, I would like us to talk about chemistry laboratory. We start by asking, what is chemistry laboratory? We say it is a special building, or simply a building, or a special room, where chemicals, not only chemistry, where chemicals and apparatus are kept, and in which practical lessons are done. Well, what do we do in a chemistry laboratory? We keep chemicals, apparatus. We also do practicals there. It's a special room. In fact, someone, if you just get to a room in a school, even if it doesn't have chemicals or apparatus, you will always know this one is or was designed to be a laboratory. So that is it. Now, like yesterday, we were looking at the physics. We looked at the laboratory rules. Every rule Every lab that must have its own rules. The lab technician should display those rules very well somewhere in the lab. And to minimize accidents. There are two common causes of accidents in the laboratory. Two common causes of accidents. One, okay, you can tell your neighbor. One, ignorance. Ignorance. We ignore things. Number two, carelessness. Carelessness. Yeah, those are the two main that causes accidents in the lab. But if we follow all the rules that I want to read to you right now, you will realize that we are going to minimize the accidents in the lab. So they're very big, but I just go through it very fast. Number one, never run while in the laboratory. Why should you run? Who is chasing you? Don't run while in the laboratory. Never run while in the laboratory, because you may trip, you may fall, you may injure yourself, or you may injure others. You know, some of you don't feel bad when they get injured. No, some of us we feel bad. So don't run, so that you can injure us. Never taste or eat anything in the lab. In fact, if I find you eating, even sometimes we provide fruits in the laboratory. If we find you eating, we will beat you. If the government questions us why are you beating the student na rule imesema tusichape wanafunzi, tutamuuliza hiyo serikali yako kati ya mwanafunzi akule sumu akufe na kipogo ile gani? Tutakutwanga kipogo. Never eat anything while in the laboratory. Leave alone eating, even testing. Don't. Always consult your teacher before trying an experiment to avoid accidents. Do you always consult your teacher? Usifike tu uanze kufanya vitu zako, hapana. Ensure your teacher is aware of what you're doing. Always consult your teacher. Label all chemicals that you are using to avoid confusion. By the way, when you get to the lab, especially the seniors from 3 and 4, whereby you are dealing with more than 10 chemicals on a table, we give you stickers or labels. We call them labels. You label solution A, B, so that when you are going on, you avoid confusion. So do the labels. If you want to scoop, this is another one. If you want to scoop reagents, use a clean spatula. After this, you tangalia apparatus and there are also spatula is used to scoop chemicals. So use a clean spatula. Another one, if you want to hold the test tube, use a test tube holder. Don't pan or don't hit some solutions in ikiwa ndani ya test tube na mkono yako, hapana, your hand will pan out. So use what? Test tube holder. While carrying out practicals in a flask, don't look at it directly with your very big eyes this way. No. Kirapa, usilete macho yako hapa bana. Wewe angalia tu kwa umbali, especially the flask, the opening side hii inaangalia kwa si kwa mtu mwingine, mahali hakuna mtu. Then view, because why? Sometimes it can spark out to your eyes. And the way the world is beautiful, ukose kuona juu ya ati uliangalia chemicals directly. Don't. If you are carrying out an experiment in which poisonous gases are produced, do it in a fume chamber or in the open air. Open air ni nje ya lab, pala nje. You do it there. Why? It will get out. There's a lot of plenty of air outside. So the air outside can easily dilute that poisonous gases and you will be safe. Or in a fume chamber whereby the poisonous gas will rise through the fume chamber, it gets out, up in the building where no one is there. Tukikupata tu ya building huko utatuambia wewe ni nani? Yes. Always keep flammable substances away from flames. Anything that can catch fire is like a flammable gas. Do it away from. Like when you're doing experiments that you are supposed to use ethanol. Ethanol is highly flammable. So make sure kuna moto hapo around. Yes. In case of any accident, report to the teacher or the lab technician immediately. Not si kesho unakuja kureport kila tukio unajua jana kuna makosa immediately. Sawa. In case of any serious accidents such as fire, I told my students this was, and they laughed. Yani moto imewaka. What are you supposed to do? Just walk out calmly this way. Pole tu. Akani kufanya mimi nimetoka kwa screen. Pole tu hivyo. Mwingine pia atoke tu pole hivi. Lakini some of you will scramble lakini mlango haitawatosha. So walk out, come, don't scramble for the exit. If you do so, it will hinder your escape. But if you walk calmly, all of you by 1 minute you are out. Kwani nikuulize ile saa mwalimu ameitana amesema okay, tutoke nje kidogo, we just stand outside there. Within like a minute or half, 1.5 minutes, you all of you are outside. But can you scramble? 5 minutes later, you will still be struggling to get out with 2 of you injured down there. Mwingine amevunjika miguu, mwingine amevunjika mkono, mwingine ameng'oka meno simply because you scrambled. You are not actually supposed to scramble. In case chemicals get into touch with your skin, what are you supposed to do? Wash it with clean water. Wash it with clean water. Yes. Lastly, always work on a clean page. Yani mahali ku clean, yani isikuwa kuna mess, kuna chupa ya nini hapa, kuna maji hapa, kuna no. Whatever you don't require, rudisha kwa kabati. Use a clean page. Right together. Now, that is rules in the laboratory. We have known what is a laboratory. Now, kuna kitu inaitwa apparatus in the laboratory. You know tutaangalia next. Sahi. But before we look at it, most apparatus are made of glass or plastic. Some of them are made of wood. But majority, 90%, are made of plastic. Why? What do you do? Yes? We have 3 reasons why the apparatus are made of glass. To allow one to see through and see the reaction taking place. You can easily observe the reaction taking place. You can even know the amount of reagents and the liquid inside the flask. That's the first reason for visibility. Number 2, glass do not react with most of the reagents used in the laboratory. Let me say with all the reagents because 99.9% of the reagents do not react with the glass. Lastly, it can be comfortably used for heating purposes. If you have a practical or experiment that requires heating to be done, you can use plastic apparatus or a piece of wood. Glass will do it very well. Yes. Now, another question. Unajua mimi tunauliza unajibu. Kama mko wawili, you can answer to your friend. Lakini kama uko peke yako, uongee peke yako venye mimi naongea huko peke yangu kwa studio. Which factor do we use to categorize apparatus? Which factor do we use to categorize apparatus? Naangalia watu wenye wako online. Okay, which factor do we use to categorize apparatus? Use. The factor is the use. The function. So we have apparatus for measuring volumes, for measuring time, for measuring mass, for measuring length, for measuring time. So 3. So we categorize basing on the use. That is it. apparatus for measuring volume. Let me give you the apparatus for measuring volume in 3 ways. I'm going to categorize them in 3. For measuring approximate volumes, exact volumes, and what else? Approximate, exact, and accurate. Apparatus for measuring volume. So there are very many. Tuanze na graduated beaker. Number 2, flasks. I'm a graduated flasks. So we are moving on. That one is measuring cylinder. Measuring cylinder. Are we still moving on? Volumetric flask. Volumetric flasks. Syringe. Syringe ni ile ukienda hospitali, the doctor will draw some medicine from a container. Na nakwambia relax your muscles. Some of you hata leo kuna mmoja wenu amerudi. Relax your muscles. Anakuwekelea hapa. Hiyo syringe ina measure exact. No, it measures the accurate volumes. Ukisema how old are you? I'm 15 years old. Wanajua yako inafaa ifike hapa. How old are you? I'm 31 years old. Yako inafika hapa. How old are you? Mostly kwa wanaanza kudanganya niko 16 na kuna 39. Niko na 16 years old. Unapewa dawa ya mtu wa 16 years kuna 39. Anyway, starting to get by. We have number 6. We have pipettes. Ipo angalia kama ni double P ama double T. Then we have curate. We have the curate. Hope you can see those. Are they visible? Yes, they're visible. Apparatus for measuring what? Volumes. Kwani mnatumia nini maziwa? So you should have in your mind. I cannot do it right now. From your notes, locate a beaker, a flask like conical flask and volumetric flask. In fact, these two. Hapa iko kama conical. Yes, so maybe you know it apparatus. There's a slight difference of the same. Measuring cylinder, syringe, pipette, and curate. More so, curate. Know how it works. Now, apparatus to measure approximate volumes ni kama graduated beakers, flasks, and measuring cylinders. This one is approximate. When you require accurate, we will use volumetric flask, syringe, pipette, and curate. Those are accurate. Lakini ukitaka now exact means it can only measure a given volume. Kama volumetric flask nimesema it measures accurate, it also measures exact, like 250 ml. Apart from 250, it cannot measure any other volume. So it measures exactly 250. Apart from pipette, kupima 25 ml, it cannot measure any other volume. It measures exact volumes. Are we together? Girls and boys? Yes. Shifting grades, where are you watching us from? Thank you. Nicolas Mwendo. Nice. Let's proceed. Now, we have very many apparatus which I will not draw right now, but I will just be reading for you. What are you supposed to know as far as apparatus are concerned? Number one, you are supposed to know the apparatus by the name and the feature, how it looks like. If you are given a diagram on the board in the exam, we will name the apparatus used or shown below. Name, give the name and the use. Be sure to do it. Number two, be sure when you are given the name, for example, somebody will give you a name like dropping funnel, and you can make a dropping funnel and give its use. In the space provided, draw a dropping funnel and give its use. So ensure you are in a position of doing that. So don't worry about that, ensure that you can do it. I'll just read for you. Number one, we have this tube. This tube looks like boiling tube. The difference is the size. This tube is very small compared to boiling tube. This tube is used for general laboratory use. Boiling tube is used when heating substances. Trough ni kando. Trough ni mechanic. Mostly in most labs, it's just locally made in the lab. You see, ile 20 liter unakata 20 liter hivi. Hiyo ya chini, that's a trough. Round bottom flask, flat bottom flask, and conical flasks. They have different use and different shapes, and all of them are flasks, but they appear differently. Yes. Lazima ni mwani watu online nione kenye wanasema. Yes, let's proceed. I'm here to confirm that iko feasible, but it's well. Someone can see what is going on. Okay. Round bottom flask used when heating substances because when it is round, the heat is distributed uniformly. Yes. Round bottom flask imekai. I may not draw a very round one, lakini inafaa ikuwe imekaa round. This one you can hit directly without using a wire case. Flat bottom flask can still be used for heating. Flat bottom flask imekai. Hapa imekuwa flat. But if you want to use this for heating, you have to use a wire case. Yes. Then we have conical flask for measuring chemicals. We have filter funnel for delivering liquids carefully into another vessel. Distal funnel, separating funnel, and dropping funnel. All of them, I would like you to know. Distal funnel do not have a tap. Distal funnel haina tap. Separating funnel iko na tap, dropping funnel iko na tap. Separating funnel is used to separate immiscible liquids. Dropping funnel used to add controllable amount of liquids into another air vessel. Controllable amount of liquids. Distal funnel inaoperate kama filter funnel. The shapes are different. Haina tap, that is distal funnel. Then we have conical flask. Conical flask is very common apparatus in the lab. What do you call it? Conical flask. Mekai. Yes. Kama sijachora vizuri, wewe chora yako vizuri bwana. Chora yako vizuri. Then we have reagent bottle for storing reagents. I not commonly used. Wash bottle is used for storing distilled water, and you will use it to rinse the apparatus. Teat pipette used for delivering liquids drop-wise. Drop-wise is either 1 drop, 2 drops, 3 drops drop-wise. Evaporating dish used for evaporating liquids. Spatula nimesema for scooping solid substances from containers. We have the gas jar for gas collection. Desiccator used for drying substance or keeping substances away from moisture, free from moisture. Then we have crucible used when heating substances that require strong heating. Then we have pipe clay triangle. Pipe clay triangle. What is the role of a pipe clay triangle? Press it to hand. Pipe clay triangle. Amejui? Oh, kumbe kuna wanafunzi, kumbe nafunza online. Nimeshangaa bwana kuna mtu anajibu. Oh, okay. Used for supporting crucibles during heating. Wire gas. Used for even distribution of heat when heating substances on floor. Kama venye nilikuwa nimedoing wire gas. Uniform heat distribution. We have tripod stand supporting beakers and flasks during heating. Mortar and pestle, and mortar. What is its use? For crushing substances. If you want to crush substances, then we will use pestle and mortar. Are you together? Good. Sawa. We have test tube rack for holding test tubes and boiling tubes. Deflagrating spoon for holding substances being burned. Tongs used to safely hold corrosive or hot solids. Test tube holder holding test tubes. Then we have clamp and stand for holding and supporting pieces of apparatus during experiments. Yes. Any question? Before I move to another set of apparatus. Apparatus for measuring temperature, thermometer. We have various types of thermometers, maximum and minimum, clinical, general use thermometer. Yeah, but mostly in the lab we work with common thermometer. It ranges around 0 to 100 degrees Celsius. Lakini ukiwa mgonjwa ukienda hospitali utapewa gani? Clinical thermometer. Apparatus for measuring mass, we have two. We have a beam balance and electronic balance. Yes, electronic balance is the most commonly used because it is easy to use and it is accurate. If you ask why we prefer electronic balance over beam balance, because it is easy to use and it is accurate. Apparatus for measuring time. Kuna apparatus mbili inatumiwa kumeasure time. That is kanda gani? stopwatch and a stop clock. I'm assembling clock. We use stopwatch if we require accurate information. For example, if we are running a race and we have to find out who is faster, we will use stopwatch. Lakini tukitumia ile stop clock, before hata isonge tumemaliza race. Now, if you want to carry out the experiment in the lab, the rate of reaction, how long does it take a piece of aluminium, magnesium, to react with hydrochloric acid? How long does it take? You will not use a stop clock. You will use stopwatch because it is accurate. Right together? Yes. That's just a minute. There's something I'm taking a lot to entertain a lesson. Someone is requesting for exams. What did the live lesson? I will do this video and exams, please talk to us, we will deliver to you. Now apparatus used as a source of heat. What will you say? Kwanza nitoe sweta huku mali tuko ni warm sana. In the meantime, when niambie which apparatus do we use to provide heat in the laboratory? Yes? Kidogo tu. At least let's go to the lab now. Apparatus for used as source of heat in the laboratory. There are very many, but we are going to focus so much on one of them. So we have kerosene stove, kuna candle, portable burner, and Bunsen burner. But Bunsen burner is the main source or the most suitable source of heat in laboratories. Sawa? Yes. So kuna maswali nataka nikupe kidogo, but allow me to fetch my water ndio tuendelee. Swali ya kwanza, what is laboratory? Explain why most apparatus are made of glass. What are the two causes of accidents in the laboratory? Putting off lamps after use is one of the safety rules in the laboratory. State 5 other rules. Give 2 apparatus used in the chemistry laboratory. For measuring volumes, measuring accurate volumes, measuring approximate volumes, measuring exact volumes, and measuring mass. You must well know. For that, I have to cool the engine by taking some water. Just a minute. Yes, I'm back. We proceed with the lesson. Kuna maswali nilikuwa nimekupea lakini sijui kama umejibu hata. Good. We can now proceed. How was the break? Let's look at the Bunsen burner. Bunsen burner, it's made of the following three parts: the chimney, the collar, and the base. So in that, I wish somebody had drawn it earlier for me. I will not draw it right now. Lakini in your course book, you cannot miss the diagram of a Bunsen burner. See, locate this part: the collar, the gas inlet, the jet, the air hole, and the base together with the chimney. You are supposed to give the function of each part, whereby we start with the base. The base is made of thick metallic material with a small hole where the jet is fitted. This base that I'm talking about is very heavy and wide to make the Bunsen burner stable. Number two, the jet allows the laboratory gas into the chimney. It allows the gas to get into the chimney. The gas inlet into the Bunsen burner is normally connected to an external rubber tube from the from the laboratory gas. Yes. Then we have the collar, which is made of a metal ring. Kasi ya collar unaizungusha. It opens or closes the air hole. If it opens the air hole, it allows air to get in. If it closes, it does not allow air to get in, and it controls the type of the flame produced. If the air hole is closed, luminous flame is produced. If it's open, non-luminous flame is produced. Chimney is a hollow tube kama hii, where the laboratory gas and the air mixes before they burn at the top of the chimney. Let me start by mentioning the two types of flames produced by a Bunsen burner. We have luminous flame, non-luminous flame. Luminous is large and wavy, and it's brown, or we can say it's yellow in color. Let's use the term yellow. Non-luminous is short and steady, and it's blue in color. Non-luminous is produced when the air hole is open because air gets in and there is complete combustion. Get me clear? Luminous, on the other hand, there is incomplete combustion of the gas. This gas, which we are calling it the laboratory gas, is made up of carbon particles. But almost every object is made up of carbon particles. So, if you close the air hole, hakuna air imekuja, so there is incomplete combustion. Oxygen is not enough. So the carbon particles which have undergone incomplete combustion glows red. And if they glow red, what happens? They produce light. That is it. First of all, what is a flame? A flame is a mass of burning gases. A flame is a mass of burning gases. If you see a large flame which is non-luminous, which is luminous, yellow in color, that is luminous, and it always burns quietly and very visible. It's bright yellow, light and wavy. It gives out light, that's why we call it luminous. It has 4 zones. It has 4 zones: thin outer region, bright yellow zone, almost colorless, blue zone, then those 4. Then it produces soot, either black, and it burns silently, as I've said. The blue zone is always down there. Yes. Now, what about non-luminous? Produced when the air hole is open. Yes, it has 3 parts: pale blue zone, green blue zone, almost colorless zone. It's short and steady, does not give out much light, yes, and it is very hot, does not produce soot. Yes. If you want to heat substance in the lab, use non-luminous. It is very hot. Wale nikupe swali hapa. Mwanafunzi anafanya practical Anton Mwende took a beaker and we have beaker A and then we have beaker B. You put water equal amounts, then when they heat the water using different types of flames, that is, ingine luminous, ingine non-luminous. Now, then this one ilikuwa na akainsert thermometer. Na akahit for several minutes, for 10 minutes. Then it was noticed that the thermometer in B recorded the highest temperature, while the thermometer in A recorded the lowest temperature. Now the question is, what was the type of the flame used in B and the type of the flame used in A? Okay, somebody. Okay, somebody. The one in the moment ilikuwa high, inamaanisha the water got heated faster. So it had the flame which produces a lot of heat, which is non-luminous. So non-luminous was used to heat B, luminous was used to heat A. State after observation made in A. Apart from the thermometer recording the lowest value, what was the other observation? Because we use that's an observation. Let me give another question. Which is the hottest part of an non-luminous flame? Which is the hottest part of an non-luminous flame? which is the hottest part of an aluminum flame. Hiyo swali nimekuachia, utajibu tuambie which is the hottest part of an aluminous flame. Yes, that's about Bunsen burner. Ukiona maswali ya Bunsen burner, I will be sending these questions to the group, my WhatsApp group yenye kuna wanafunzi. So if you are a student, you're watching this, please, what are you supposed to do? Inbox that number nilikuwa nimeandika hapo 6740 62925 to be added to the group so that we can revise the questions we have over here. I wish you the best. Thank you for joining me. Thank you for staying with me. Thank you for following me. And keep on following me. Blessings. Allow me to put it off. 1, 2.